I'd like to present some of my paper with regarding configuration study of the scale and the circular shape substrate for an after treatment device for diesel engine, which is called, we can say, stationary engine. And for the introduction, I wrote in this way, after treatment system for emergency generators. During the weekly test operation, the large amount of harmful emissions such as NOx and PM is going to be generated. So it is very harmful emissions, so we have to get rid of those emissions. And for emergency generators, basically reduce the harmful emissions through the same type of post-treatment, after treatment, you can say, system installed to unload the diesel engine. So to reduce the through the DLC and the DPF as a shell, which those after treatment technologies, which is presently applied to stationary engine or diesel automobile engine. So for the introduction, I try to mention about the DPF, which is called the diesel fluctuating filter. This is for the research survey. I wrote in this way. Layers structure called cake layer, and then there are many different materials to substrate for the DPF. There is one of the ceramic filter. The other one is metal filter, such like that. There are many different after treatment technology material, which is very important. We have to take out the ash and the soot accumulated during the PM filtrations. This is we need some more technology to get rid of ash come from the engine where fuel and oil additives and corrode is just manifold. And another thing which we have to be very cautious about the soot. Soot is relatively rich and firm near the central edges of unburned fuel spray, and react with oxygen to partially oxidize, but the remaining parts they can be oxidized and are discharged to DPF. So ash and the soot is accumulated along the inner or filter, which is, you can say, the substrate, and the rest is accumulated as the flow located at the end of flood of each layer. For the DPF fundamentals, we have to optimize the accumulation period of dust in the DPF. Usually, the DPF substrate manufactured in the asymmetric cell technology, so can minimize the pressure drop and the curve when the accumulation of dust is large by designing the intake channel with an outlet channel with the DPF deforming. So another thing is very important thing we can say regeneration method. As long as the automobile has to be continually moving, so for that is the different. That point is different from the stationary engine. So we have to apply the regeneration technology to move to vehicle. Regeneration DPF through the diesel funnel has a relatively simple engine, top control and less dilution of oil by fuel is widely used. Another technology like this, the plasma emission diesel burner using circular plasma, which has a superior combustion efficiency compared to the conventional diesel burner, as ignition source has been studied. And also we have to focus, we have to study on this for the visualization of the flow through the PIV technology, which is very numerical. There's a visualization technology in the fluid dynamics. And to understand the combustion characteristics of soot particles accumulated inside the DPF generation, distribution of the ash component can be analyzed by inductively coupled plasma mass spectrometry techniques. Efficient DPF regeneration is possible if fuel injection is precisely controlled when monitoring the reduction rate of the accumulated ash and the soot in DPF. And another technology we can also mention in this, which is called DOC. It's called the diesel oxidation catalyst technology. Placed in front of DPF and convert anode along the exhaust gas component to NO2 or NOx, which is called NOx, can react with the soot particle to oxidize some of the soot particles to be accumulated in the DPF. And also there is some another emissions economic compound can be delivered through the DOC. It's called HC, hydrocarbon. It is discharged from the EOC, and heat generated during the oxidation reaction is used to increase the temperature for regeneration of DPF. So we have to mention about this one, the DPF temperature. This is very important for the regeneration, for DPF regeneration process. Because exhaust temperature of DPF front and can be raised up to 700 Celsius, and the rear temperature is 520 Celsius when hydrogen is supplied. DPF regeneration process can be completed in just 10 minutes. This is for the this was for the introduction from general information for DOC and DPF. From now on, I'm going to introduce main topics of study. It is necessary to compare the flow characteristics reduction efficiency of after treatment system of a scale carrier means substrate configuration, and the after treatment system of circular substrate configuration. Basically, we're going to study, we apply this CFD technology to understand inside flow in substrate. So, using CFD analysis has the advantage of reducing time and cost required to follow uniformity analysis, which is difficult to grasp by experimental method. So this is kind of advantage to use the CFD technology instead of experimental technology. That's the reduction method of after treatment system according to the various design variables study. This is so-called this analysis is related to the numerical analysis, which is called the CFD analysis. This is the figures we are focusing on this kind of thing. This is schematic of PM and NOx reduction overall system. This is the inlet inside the flow. This is DOC or DPF, DOC and the DPF, and the urea injection in there. So we can reduce the NOx. Okay, we can reduce the PM. We can reduce the HC and PM like this. So there are three different after treatment has been combined together. So we can reduce all those emissions and then we can take out and then we can have more fresh air from in outlet. And another thing let's go back to the method. In consideration of fabrication, catalysts such as DOC, DTF and SSR was composed of steel substrate like this one, and all four areas except for the catalyst was formed in circular shape. And also for the numerical analysis, we used RNG, K-epsilon, tolerance models was applied to the analysis. And the porous material, because the substrate has the different pore mesh, so we can use the porous material which is provided from the CFD analysis. Let's look at the analysis conditions for the Urea Association system. This system considers the typical chemical reactions of SCR, such as processes and hydrolysis and the SCR reduction. Urea injected from the urea injector located in the reaction is polarized to generalized isoclinic acid, which is called the HCl, and ammonia is generated through the hydrolysis reaction in the mixing area, so that the exhaust gas, including ammonia, flows into the SCR substrate through the diffuser. After this process, NOx is converted into N2 and H2O through the reaction, the reduction reaction of SCR in the catalyst, thereby reducing NOx emissions. And for the uniform, you can let's define the uniformity index, which is very important for this analysis. This is defined in this way. This is related to some. This is kind of related to the geometrical of the substrate of the after treatment system. This is very important again. And let's look at some. We use the porous material, medium material like this. Okay. We refer to that kind of things. For the boundary conditions, this is a very important thing because this is the boundary condition is a wrong boundary condition has been. If wrong boundary condition was given, the solution is not correct. So we are very cautious about for supply boundary conditions like this. But in this case, we apply this kind of boundary conditions. Because the mass flow rate is a value like this, and then we have different any load. This is full load is 35. This is 40 different flow to be segregated, and outlet 1 and ATM atmosphere temperature, atmosphere pressure, and the temperature is like this, and then we have this system like this. Okay, so this is boundary condition, so we can apply to calculate This is also basically we using the Navier applications and RNG cables models for the turbulence models like this. This is a flow or rate distribution, rectangular type of the substrate, like this. The flow velocity increased about 55 meters per second in DOC, and the dpf made of porous material decreased to about 27 meters per second immediately after passing through the filter. And that turbulent flow is formed by the mixer. Finally, the velocity of the reactor section goes about to 37 meters per second. This is, look at this one, it's the velocity magnitude of the schematic rectangular type of substrate, like this, and then there is inlet and outlet. This is HTC, is a hydrocarbon injection. This is from the pure injection. This pure is and then this is Urea injection. And the standard mixer designed like this. This is a flat. So we are mixing this half the Urea mixing together. So this is much more mix. We have to mix the Urea. This is kind of result we can see. This is different according to the shape of the substrate. Look at this is a circular type, and this is a rectangular type, and then I guess this one is a circular type. This is a rectangular type. This is a circular type. This is rectangular type, and then this is a different roads. This one. Yes. Look at this one, the 25 road and 100 may have the color is different. This is much more thin one. Thicker one is we have more ammonia distribution has been found in this way. Yes. But look at this one. It's a little bit. This one is not grown. This is not grown, but this is, you can see, much more thicker than this. Okay? As mentioned about difference of according to the shape of substrate. Full distribution of by load that we saw from previous figures. Rectangular type, by low load, ammonia was not sufficiently distributed on the world surface due to that zone. Generally, at the corners when flow velocity was not sufficiently secured. However, as the load increased, the flow rate increased relatively. A large amount of ammonia is distributed to the world surface. On the other hand, circular type, there is no corners that are severely restricted by the flow, like the rectangular substrate, so that relatively even distribution is shown. But when the flow velocity increased, as the load increased, the phenomenon that of our ammonia is locally concentrated on the world, the surface appears. And also, we can see another thing here. It's called the flow distribution by load conditions. As a result of this, the load increased the flow uniformity of both the square substrate and the circular substrate is improved. But the amount of improvement is relatively larger for the scale substrate and for the circular carrier or substrate. This figure mentioned, we can see in one's there is different in load and the uniformity. So this is a circular one. This is a rectangular one. So obviously, we can see which one is higher one is this one, the circular one. Circular is much, I guess, circular is better one. But look at here, circular carrier is an advantage. It's good, better than this. In low flow rate, but there is no large difference in the efficiency between the two carriers in high load area with a large flow. This is the low, and the lower one is this one is much advantage. But there's a load is increased. This is advantage is not too much difference. Okay? Let's look at some other view of difference by spray position of layer. This which position is better one. Okay, let's look at sometimes we have two different cases here. We designated 4 different locations in this way. Another one here is this is mixing, and then this is injector here. Another one here, injector here. The other side, and we have 4 different locations designated and applied in this system. Okay? Because this is possible, we can use the shear free energy. So look at this, look at this ammonia distribution like this. Okay? Which is, I guess, which is the best one. Anyway, let's look at some other things we summarize in this way. Case 1, the distribution of ammonia in the central part is big and evenly distributed in the overall state, but the concentration decreased significantly as it approached the wall, and the relative ammonia concentration decreased considerably in the 4 corners. For the case 2, the effect of the turbulent formation by the mixer decreased, and the ammonia was concentrated in the center. However, the overall ammonia distribution characteristics did not show much difference from case 1. Case 3, okay, ammonia injected in the reverse direction method with the turbulent just flow formed by the mixer, and quickly mixed, showing higher flow uniformity compared to case 1 and 2. However, when the just flow rate, the flow rate of urea solution meets in opposite direction in the total flow or rate decrease. It's called, which is causing phenomena in which ammonia is is no good in the bottom. We expected it in this way. Anyway, we pray some other things, and we can, the other side we can, okay. But anyway, it's no good. For the 4 cases, freshly sprayed urea is mixed by a mixer, and uniform of SCR shows the highest flow uniformity according to the flow arrangement cases. And most of the advantage arrangement in terms of that, this is good. Okay, so previous like this is much better. No, this is thicker, too much thicker like this, but this is much more. So this is this position is very good. Okay. Let's look at some other graphs in this way. Look at here. This is uniformity and uniformity and the base back pressure. So we have to find how much effect on the uniformity and the back pressure. This is a very important parameter to analyze this kind of system. This is uniformity like this. We can call the case 1, 2, 3, 4 cases. Let's look at this is back pressure. We have to very cautious about the back pressure. Back pressure has to be decreased. Yeah, back pressure has to be decreased. Uniformity has to be increased like this. This is much better one. But look at the cases. Case 1 cases are like this, and 85, 75, and you're like this. So you can see obviously uniformity which this is much more better one. Okay, 92, and the back pressure, this is much lower. Okay, this is good. Okay, this is good, and this is good. Okay, back pressure much more decreased has to be. Okay, so okay. When considering back pressure and the flow uniformity, case 4, which is arranged the mixture at the rear of the injector, can be seen as the most efficient arrangement. So, okay. Actually, this is not too much differences like this. So this one difference here, this one is uniformity much more significant numbers difference. So we can choose this case 4 case. Here is this is the uniformity and the back pressure for the this is another case. This is DOF, DOC, and the DPF in porosity change according to the back pressure and uniformity like this. And this is back pressure decrease here. Okay, decrease. The low one is good. Okay, this one is very good. This is very bad. Uniformity, which one is good? Uniformity is higher one. So this one is good. So this one is good. Okay. Okay. So let's look at some other view of the things, the flow porosity. As described, the porosity increased under the same condition. It just flow resistance generated when the passing through the channel of filter decreased and the back pressure decreased by near 50%. In addition, as the porosity increased, the flow uniformity also increased, improving up to about 95%. However, when the porosity increased 70%, there was little change of flow uniformity, even if the porosity was increased. This is comparison of distribution of ammonia in front of the SCR. When porosity is 70% and 90%, there is no significant difference in the distribution characteristics. This is ammonia difference something like this, and there is no difference. Let's make some conclusion. Here is skin substrate has lower flow velocity and the flow uniformity compared to the circular substrate, but the difference decreased as engine load factor. increased. Secondly, as the urea injector was moved away from the mixer, the flow uniformity decreased when placed in the opposite direction to the exhaust flow. The flow uniformity increased, but the back pressure increased. Finally, the flow velocity decreased. When the urea injector is placed in front of the mixer, the highest flow uniformity and the reduction efficiency can be expected. When the porosity of the filter is increased, the velocity and pressure, the pressure is greatly decreased and the flow uniformity is also improved. But when the porosity exceeds a certain level, the flow uniformity does not increase anymore.